Hello, my name is Jeremy Winsor. I am the life science teacher at Fulton High School. We've started a project that we're terming Aquaponics in the classroom. This video is over pH in our aquaponics system. I will not pretend to be any expert in aquaponics. This is a learning experience for me, just the same as it is for my students. First, what is pH? pH stands for potential hydrogen. I've also seen it termed power of hydrogen. It's a measure on a scale of 0 to 14. So we can see the scale here. 7 would be neutral. Anything on the high end of 7, from 7 to 14, would be alkaline. From 7 down to 0 would be acidic. So the importance of pH, we've got many organisms that have a narrow tolerance of pH. So our fish and our bacteria in our system are going to prefer a slightly alkaline system from pH of 7 to pH of 8. Our plants, on the other hand, are going to prefer a slightly acidic range from 5.5 to 6.5. So through a little bit of research and kind of looking into what we're expecting our system to do, as we add fish to our system and as bacteria start to culture in it, through the nitrogen cycle, we're expecting bacteria to give off nitric acid, so HNO3. And so right now we are actually sitting at a pH somewhere between 8.2 and 8.5, so we're a little high on the pH scale. Ultimately, our hope is that this will promote beneficial bacteria growth, and our system will eventually, as nitric acid is produced, will eventually bring down that pH. So why is our system alkaline right now? Our thoughts are that we have a large number of carbonates in our water. So calcium, magnesium, and potassium are found in the well water that we have here at the school. We also run a softener system, so that could be contributing to our basic levels of pH. So there's two types of hardness, carbonate hardness and general hardness. We're going to look at each one of those. Carbonate hardness, or carbonate alkalinity, is a measure of the alkalinity of water caused by the presence of carbonate and bicarbonate. It's usually expressed in parts per million, and that's what we're measuring ours in, either parts per million or milligrams per liter. It's our largest effect on our system's pH, and it's also going to work like a buffer. So it's going to maintain our overall pH as acid is added to it, as nitric acid is added to our system. It's going to keep that system from dropping drastically and causing drastic fluctuations in our pH. We don't want major swings in pH. The major swings in pH are going to lead to fish death. General hardness is a measure of the concentration of calcium and magnesium. So we're measuring hardness using an API general and carbonate hardness test kit. We want our carbonate hardness to be at least 4. The higher the carbonate hardness, the better our system will work as a buffer. And so if we are not at 4, we want to build that up by adding potassium bicarbonate. And then we've got some instructions down here for how to do that. Right now, we aren't too worried about adding any potassium bicarbonate. When we did our carbonate hardness test, we actually maxed out the chart on this API kit. We had more than 12 drops added for the carbonate hardness. And so we are well above 214 parts per million of our carbonate. In order to decrease the pH, if we need to do that in the future, we're going to add phosphoric acid, and that'll decrease the overall pH in our system. Phosphoric acid is the same stuff that you would find inside of many colas. So why wouldn't we use citric acid? You would think that citric acid would be quite a bit safer for a system like this. what we find is that actually citric acid kills bacteria, and we want those bacteria in our system. The bacteria are going to help to promote the movement of the nitrogen cycle inside of our system. So taking the ammonia, converting it to nitrite, and converting that to nitrate, ultimately we want that to happen, and without bacteria, the nitrogen cycle is not going to function correctly. So how are we going to go about increasing pH if we need to increase the pH? In that case, we're going to add either a carbonate or a hydroxide. In this case, we prefer carbonates, mostly because they're going to serve as a buffer as well. So we can add calcium carbonate or potassium carbonate. Calcium carbonate, we should be familiar with it being just simply in seashells. So it's going to not really cause very many problems inside of our system. It's very natural. And then when we add those two substances, we want to make sure that we're taking them and we're mixing them separately in their own cups of water so that they don't bind together with one another. If we mix them together and then try to dissolve them in solution, we'll find that they clump together. And then as we dump them in the system, we've got large clumps of these materials.